Welcome back to another section 2 on chapter 9. Here we're going to look at piecewise functions. Now, piecewise functions, this one's going to take a little bit longer just because there's more parts to it. I know I wish they could all be 6.5 minutes, but it's not, it doesn't happen that way. Anyway, a piecewise function is kind of a weird function. I want to say it's a new type of function, but it's not particularly new. An example of a piecewise function is actually this blue graph that's graphed right here on the screen. This is a piecewise function. By the end of today, you should be able to make an equation, one equation that makes that graph. But we're not quite there yet. So, first of all, learning targets. First one, I can write and graph piecewise functions. Second one, I can use piecewise functions to describe real-world situations. A lot of times, piecewise functions are going to describe real-world situations better than most other functions, simply because it changes. It's not just one thing going up or a quadratic that goes on, things that go on and on forever. Piecewise functions cannot do that. So, we're going to start this out a little bit different. Instead of starting directly with instruction, we're going to start with an exploration for you guys to do. Now, this stuff involves only stuff that you've already done before, so you should be able to do this. We're going to start out with a problem. The graph shows a 10-hour training session for a bicycle racer. The session consists of 3 different stages. And then we have time as our x-axis, distance as our y-axis. We have stage 1, stage 2, and stage 3. All of these are straight lines, so there's nothing weird where it's a curve, but we just can't see the curve. And so the questions, 1, write a verbal description of the training session. All right, you don't have to write it. Say it out loud, say it in your head, but what is this doing? The second one, what is the cyclist speed during each stage of the training session? Right, being that we measure speed in miles per hour, how do you think you would find speed from this graph? The third one, write a linear equation for each stage of the training session, where x is time and y is distance. And then hint, use the point slope form for the equation of a line. That will help. And then question 4, what is the domain for each stage of the training session? Remember, domain is x, so time. So go ahead, try working on these 3 questions, because 1 you don't really have to do anything for. And then when you're ready, come on back. All right, did you get them? Do you think you got them? Did you actually do it? Do you need to go back? Did you do it? If you didn't do it, go back and do it. This is going to be important for the lesson. So, now that you've actually done it, yes, go back and do it. All right, now that you've actually done it, let's look at these. So, the first one, write a verbal description. Well, it goes up, then it gets a little bit steeper, then it gets less steep. You can be more detailed with times. The steepness would be the speed. When it gets steeper, it's going faster. Then when it gets less steep, it's going slower. And speaking of speed, what's the speed during each of the sessions? Well, as you just mentioned, the speed is going to be the slope. If you didn't get that, go back and calculate it, although you probably calculated the slope for problem 3 anyway. So in stage 1, it's just we went up 30 and over 2, so 30 over 2 is 15. For stage 2, slope is y minus y, so we got up to 90 minus 30 over 5 minus 2. Could have also gone, all right, so from 30 up to 90, so we went up 60, and we went over 3, and we end up with 20. Yeah, I hope you've noticed that the lines aren't the same. The y lines are each 10, the x lines are each 1, so you can't just count lines. Oh, we went up 3 and over 2. Now we went up 30 and over 2. Then stage 3, 150 minus 90 over 10 minus 5, which is going to give us 60 over 5, which is 12. All right, and question 3, the equations of the lines. So the first one, y minus 0 equals 15 times x minus 0. I use 0, 0 for the point here, just because it's easier. We could have used 2, 30. That would have been okay, but again, easier, because this simplifies to just y equals 15x. Stage 2, I'm going to use the smaller of the 2 points just because the numbers are smaller and easier to work with. So y minus 30 equals 20 times x minus 2. Could have gone y minus 90 equals 20 times x minus 5 if we wanted to. We'd end up with the same thing. But here we're going to distribute the 20 to get 20x minus 40. Add the 30 over. Y equals 20x minus 10. If we extended this line backwards, does it make sense it would hit at about negative 10? Yeah. And then stage 3, again, I use the smaller of the 2 points. Y minus 90 equals 12 times x minus 5. Distribute to 12. Add the 90. Y equals 12x plus 30. If we extended this backwards, it would hit about 30. So that makes sense. All right, and then the domains. What's the domain? The domain's the x-axis. So the first stage, we're just from 0 to 2. So 0 is less than or equal to x is less than or equal to 2. Second stage is from 2 to 5. So 2 is less than x is less than or equal to 5. You might be thinking, wait a second, this one's just less than, but the rest of them are less than or equal to. True. 2, the actual point 2, when the hour clicks over to 2, is going to be in either stage 1 or stage 2. It will not be in both. Being that it's actually happening at the same place, it doesn't matter which one it is. I could have made this one a less than, and this one a less than or equal to. One of them is less than, one of them is less than or equal to. It doesn't matter which. Same thing for the 5. Happens in the same place. The next one for stage 3, 5 is less than x is less than or equal to 10. So, again, it can't be equal to in 2 stages. It's in one stage or the other. And so, here we have the 3 equations, we have 3 domains, we have our 3 slopes. So we can write each piece of it, but how do we write it all together as just one equation? Well, that's what we're going to see next. And the nice thing is that we've already done, I want to say most of the work. We've already done all of the work. So let's pull our equations back up. We have y equals 15x, y equals 20x minus 10, y equals 12x plus 30, and our domains. And then, when we write a piecewise function, we're going to have y equals, or most likely f of x equals. Then we're going to get a big one of those squiggly brackets. And then in here, we're going to get our equations. And so, our equations, which just change color so we can see where they're going, or maybe they didn't change color, then we'll never know. We're just going to take this equation and we're going to move it up here. So we get 15x. We're going to take this one, then move it up there, and we're going to take this one and move it up there. So we actually write each of the equations, each of the pieces, completely separately, and we put them in. And then we're going to take our domains, and we're going to match our domains. So the stage 1 equation gets the stage 1 domain. The stage 2 equation gets the stage 2 domain, and the stage 3 equation gets the stage 3 domain. And so it's 15x when x is between 0 and 2. It's 20x minus 10 when x is between 2 and 5, and it's 12x plus 30 when x is between 5 and 10. Now we generally have something in between here. I've seen many things. I've seen commas. I've seen the word when. The book is pretty consistent on using the word if. So it's 15x if 0 is less than or equal to x is less than or equal to 2. 20x minus 10 if 2 is less than x, which is less than or equal to 5. And 12x plus 30 if 5 is less than x is less than or equal to 10. And so that's the piecewise function. That's one function to describe this whole situation. So let's see if we can write a couple. So admission prices. And this is a great example of where you'd see piecewise functions in the real world. Prices go by age group. If you're less than 7, you get charged $5. If you're in between 7 and 12, you get charged $20. And if you're over 12, you get charged $45. Anything with a step cost. If you want to buy seats for a concert, depending on the type of seat you want, it's going to cost you differently. If you're going to a buffet, you're going to get something kind of like this, where it costs you a different amount depending on your age. And so there's a lot of things like this. Now, while we're looking at these are two different types of functions. This one up here is called a continuous function because there's no breaks in it. This one down here is called a discontinuous function because there's big gaps. You're going along here, and it jumps up here. You're going along, and then it jumps. Up here, it didn't matter which place got the or equal to, but down here it does, right? This one's going to get the or equal to here, not this one. And then same thing, this one's going to get the or equal to, not this one, because the closed circle instead of the open circle. And so let's look at the equations for this. Oh, and when it's a bunch of horizontal lines like this, it's what's called a step function. Not because we have like parent functions and step functions, but step function is in, it looks like stairs. So, our equation, y equals f of x equals, well, the first one, it's just 5 from 0 to 7. So 5 if x is between 0 and 7. Notice it's just less than here. Second one, 20 from 7 to 12. So 20 if 7 is less than x, less than or equal to x, and 20 if 7 is less than or equal to x, which is less than 12. And the last one, 45, if x is greater than or equal to 12. And that's it. Now, is there a cutoff for the age? Well, theoretically, yes, and eventually, but it's really not that applicable to admission prices. So let's look at another one. Here's one that looks a lot like the one that's on that front page of the video. So we again have 3 pieces. It doesn't have to have 3. We could have 2 pieces. We could have 15 pieces. If we did have 15 pieces, it would probably be a step function, by the way. But 3 is kind of a nice number. Usually it's 2 or 3 in what we'll be working with. So y equals f of x equals, and this one, see, it's just a horizontal line at 4, so it's just y equals 4. That'll be when x is less than negative 2. Is it less than, or is it less than or equal to? Well, it doesn't matter. It's the same place. So one of them will get a less than, one of them will get less than or equal to. So here, let's just go less than. It's 4 if x is less than negative 2. Then how about in between negative 2 and positive 2? This looks like something. Oh, that looks kind of like a quadratic. Oh, what's the equation for a quadratic? Starts out x squared. Let's see, 0 squared is 0. 1 squared is 1. Negative 2 squared is 4. Hey, look, just x squared. So you have y equals x squared in between negative 2 and 2. Yes, you will get some quadratics, but rarely will there be much more than x squared when we're doing this. It might be like x squared minus 1 or something where we'll do a little vertical translation, but we won't see much beyond that. Definitely nothing like we dealt with in the quadratics chapter. And then how about the last piece? And so notice here we have just less than. So here this will be x is greater than or equal to 2. And we have a line. So slope is 1. Now, one of the big mistakes here, and this is something people make, is they'll be like, all right, so 1x plus 4 because it starts at 4. No. Where's the y-intercept here? Oh, we could follow it back down to 2. So y equals 1x plus 2. Or we can plug in our point. Y minus 4 equals 1 times x minus 2. And then we can distribute there. But either way, we end up with x plus 2 if x is greater than or equal to 2. And so that idea is the same as here. Our y-intercept was 30. It's not at 30, but if we follow it all the way back, we get to 30. Again, that's one of the big mistakes. People just go where they start with. And so that's writing piecewise functions. We're just doing each piece completely separately. You'll have horizontal lines, which are just a number. you'll have linear lines, and you'll have a little bit of quadratic stuff that's easy mode quadratic stuff. All right, the next piece, evaluating piecewise functions. We're going to plug in points. And so let's look at some. Let's get an example. F of x equals negative x if x is less than negative 1, x squared if negative 1 is less than or equal to x is less than 2, and 7 if x is greater than or equal to 2. And we're going to evaluate for x equals negative 2. So the very first thing we need to look at is which piece do we plug it into. We have to look at the domain. The big mistake here is people like to give me 3 answers. There's only one answer. We look at the domain, negative 2. Where does negative 2 fit? Is it less than negative 1, in between negative 1 and 2, or bigger than 2? Well, negative 2 is less than negative 1, so we plug it in here. We get f of negative 2 equals negative 2. When negative 2 is just positive 2. So, f of negative 2 equals 2. We don't plug it into the others. It doesn't equal 7. It doesn't equal 4. It's just 2. All right, let's plug in another one. X equals 1. Where does 1 fit in? That 1 is right in between here. So we plug it in here. F of 1 equals 1 squared. So f of 1 equals 1. How about x equals 2? Well, here's 2, but here's 2. Where does it actually equal 2? It actually equals 2 here. And so we'd plug it in here, and we get f of 2 equals 7. There's no x there, so it just equals 7. It's the horizontal line. So here there's a gap, kind of like we saw a gap on the step function. If we were to plug in 1.999, 1.999 is less than 2, so we'd plug it in here. And we get f of 1.999 is 1.999 squared, which is basically 4. Not quite 4, but basically 4. And so it jumps from being 4 to being 7. But when x equals 2, we do plug it into the one where it's actually equal. If we plugged in 2 to both of these and they came out to be the same thing, it would be continuous there. So let's see if you can try some of these. So I'll give you one. There's only 2 of them here. So g of x equals 5x minus 9 if x is less than 2, and 4 minus x squared if x is greater than or equal to 2. And then plug it in for x equals 0, x equals 1, and x equals 2. So go ahead, pause this, plug those in. Remember, there should be only one answer for each of these, and then come back when you're done. All right, ready to take a look at these? So, plugging in 0. Well, 0 is less than 2, so we'd plug it into this one. G of 0 equals 5 times 0 minus 9. Well, that's 0, so it's just negative 9. X equals 1. 1 is less than 2, but we already used that one. Doesn't matter. These both are less than 2. All of them could actually go into one of them. You might not even use the rest of them. And that happens a bit with these. You'll get a 3-equation piecewise function. It'll tell you to plug in 2 things. They might go to the same thing, but you're definitely not going to get all 3 of them. Anyway, we plug it in. 1's less than 2. So 5x minus 9. 5 times 1 minus 9. 5 times 1 is 5 minus 9 is negative 4. Then x equals 2. Well, here's where it's equal to. So we'll plug it into this one. 4 minus 2 squared. 2 squared is 4. 4 minus 4. F of 2 equals 0. How'd you do on those? Pretty easy. I hope you didn't give me 2 answers to each of them, because you only plug them into one of the 2 pieces. So that's evaluating. It's possible you'll be evaluating on a graph. You just go to where x is, then go when x equals 2, what does y equal? Same thing we've always done when evaluating from a graph. And then the last piece, speaking of graph, we're going to graph these piecewise functions. So let's start out with a piecewise function, x plus 6 if x is less than negative 2, x squared if negative 2 is less than or equal to x is less than 1, and 3 if x is greater than or equal to 1. So first, before we see what the graph is, let's see what the graph isn't. Oh, we have some colors, maybe, so that we can see which graph is which. And then we have this. This is not the graph. Because first of all, this isn't a function. Vertical line test does not work here. But it's not the graph because over here, the red one, we should only have the red line because this is the red domain. Here, we should only have the blue line because this is the blue domain. And over here, we should only have the green line because that's the green domain. So how could you graph these? There's a couple ways. One way, for this line, we could graph the line, right, like that, in pencil. Because then we'd see like, oh wait, we just want when it's less than negative 2, and so we could erase this piece. But sometimes it's handy to have that y-intercept, because that's how we graph the line. And so that's one way. We could actually graph the whole thing and then erase the part we don't want. The other way is we can plug in points. I'm going to plug in negative 2. I know that x can't equal negative 2, but it'll be right there. So I'm going to plug in negative 2. Negative 2 plus 6 is 4. And so x will go right up to 4. It's a line with a slope of 1. So at negative 2, I'm going to be at 4. And then I can go with a slope of 1 backwards. Right? And then here we'd have an open dot. Except as we saw previously when we had all of them, they actually do intersect here. So we don't need an open dot. For the blue one, plug in some values, plug in the endpoints. Negative 2 squared is 4. See, they're the same place. So we don't need an open circle and then it goes right to the same thing. That's just silly. Plug in 1, we get 1. So we're going to start here. We're going to end here. And what happens in the middle, it's a quadratic, but let's plug in 0 just so we get a number. So 0 squared is 0. And so start there, go around all the way to there. Now here, it's just less than 1. So we do need an open dot on that. And then for the green one, it's just y equals 3. And it starts at 1, goes that way. There's not much to do. I just start there, straight line that way, and there we have it. There's our piecewise function graph. Again, don't graph the whole thing of all of them. You shouldn't have anything overlapping x values because it is a function, so we only have these. Anyway, that's piecewise functions. There's a lot of pieces to it. We have writing the functions from a graph, evaluating for pieces, and graphing the functions from the equation. So lots of different things to do here. Again, there's nothing new other than we're taking some stuff we already know and we're putting it together into one equation. Anyway, I will see you in class and we'll have some problems to work on, and I'll see you then.